Hello, welcome back to our little corner on the web, where we go through math problems to hopefully inspire and encourage interest in math. Today, we will go over questions 9 and 10 from the 26 PMO area stage. Okay. Question 9. Let n be the number of ways all the letters of the word Olympiad can be placed in squares of a 3x3 tic-tac-toe board. At most one letter per square, such that no two vowels are in the same column and no two vowels are in the same row. What are the first three digits of n? Recall, A, E, I, O, U are vowels. Okay, so we have a tic-tac-toe board. And we have three vowels here. So let's try to place the vowels in first, right? So we're told that no two are in the same column and no two are in the same row. So that means that if we were to choose where to place them, the first vowel will have three choices to go from if we're looking at the first row, right? But once we've chosen, we're basically left with the virtual square, meaning if we chose this thing here, we're left with this square here, right? And if we chose the middle, like, let me switch colors here. If we chose this one, well, we basically invalidated those two. We still have a 2x2 square, okay? So the first choice, we have three choices for where to put it on the top. We have two choices then. If we go down one, right? We have, if we maintain on the blue, we have this or this choice. And the last one is basically defined. So there's three factorial ways of choosing where to put the vowels. And there's three factorial ways of arranging where, which one to put first, O, I, or A. So there's three factorial ways of doing both of those, okay? So the last one is now, the last five letters, right? The LYMPD. So we have now 6 spots left for the 5 letters. So that means there's 6 times 5 times 4 times 3 times 2 ways of putting those 5 letters. That's basically just 6 factorial. So we have 3 factorial times 3 factorial times 6 factorial ways of basically putting all of them into the right spot. Okay, 3 factorial is 6, so 6 times 6 times, and 6 factorial is no more than 720. So we have 720, or we just want the first 3 digits. So we really have 720 times 36, 72 times 36, right? So that is 3, 6, 21. So it's 2592. Well, if you wanted to 00, but it's basically 259. Okay, so the first 3 digits of n is no more than 259. Okay, so that pretty much is all the things that's happening in this question. So we'll move to the next question. So question 10. Fern writes down all the integers from 1 to 999 that do not contain the digit 2 in increasing order. Stark writes down all the integers from 1 to 999 that do not contain the digit 6 in increasing order. How many numbers are written in both their lists in the same position? Okay, so here I just basically tried things out, right? So I'll put Fern in blue and Stark in red. So Fern would have written 1, 3, 4, 5, 6, 7, 8, 9. If we're doing this from 0 through 9, right? And Stark would have written 1, 2, 3, 4, 5, 7, 8, 9. So as you can see, 1 matches, right? 7, 8, and 9 matches. So here there's 4. Okay. if you try to do it for 10 through 19, what you notice is you have 10, 11, 13, 14, 15, 16, 17, 18, 19, and Stark would have the same thing at the 10s, 11, but then we'll differ here. Okay, so here there's 5 things that match, the front 2 and the back 2. Hopefully it's obvious that 20 to 69, there's nothing that matches in 20 through 69 because one of them will skip the 20s, which means that they're offset by 10 integers, and it doesn't catch up until the 7s. 7s actually follow the exact same pattern here. There's also 5, and so does 80s and 90s. So to maintain symmetry, I will add just 2 things. Just begin it first with 0 to 0. So that means that for the numbers less than 100, there's actually 25 of them, right? So if we assume that we're going to start first from 0 to 9, there's 5. 10 through 19, there's 5. 70 to 79, there's 5. 80 through 89, and also 90 to 99. Each of those have 5. So now the only question is, how many of the hundreds digit work? Okay. Well, following the same pattern, the only hundreds digits that work will be hundreds digits with 0, 1, 7, 8, and 9. Okay. This means that there's 500 digits that work. So we have 25 times 5 patterns that will work, meaning that they're in the same position. But as I said, I added this extra case to help with the symmetry. So I have to subtract 1. So the total number of numbers that are in both lists and in the same position is 124. Hopefully you found these solutions educational. If you did, do hit this like button and subscribe. Thank you for watching.